This is Module 6, our fraction review. In this module, we're going to look at equivalent fractions, multiplying and dividing fractions, and adding and subtracting fractions very briefly as a review. Prime and composite numbers. A prime number is a natural number greater than 1 whose only factors are 1 and itself. The first few prime numbers are 2, 3, 5, 7, 11, and so on. And the way you recognize prime numbers is you cannot divide a prime number by anything evenly other than itself or 1. In other words, the only way you could break down 3 would be 1 times 3. You can't divide a 2 out of it. You can't divide any other whole number out of it and get another whole number. A composite number is a natural number greater than 1 that is not prime. It's important to remember that a factor is any number that divides a number evenly with a remainder of 0. For example, if we were looking at numbers like, let's say 12, and we asked to find 2 factors of 12, there are several factors of 12. One way that you could break 12 down would be 1 times 12. Both of those numbers divide evenly out of 12 with a remainder of 0. Another possibility would be you could factor out a 2. 2 divides evenly out of 12 and leaves you with 6. So by default, 6 also is a factor of 12 because 6 also divides evenly out and, of course, leaves you with 2. So order of factors is not important. Another possibility would be you can divide a 3 out of 12, and that leaves you with 4, no remainder. Notice that, again, you could divide 4 out because order here doesn't really matter. If you divide 4 out of 12, you're left with 3. You cannot divide 12 by 5, however, and get a nice even number. So 5 is not a factor of 12. 6 is, we already talked about 6, that occurs up here. 7 is not a factor because 12 divided by 7 gives you a remainder. 8 is not a factor for the same reason. 12 divided by 8 leaves you with a remainder. 9 is not a factor. 10 is not a factor. 11 is not a factor. And so we now have a listing of all the factors of 12. If you wanted to list them out in column form, factors of 12 then are all the numbers that you can divide evenly out of 12. Those factors then would be 1, 2, 3, 4. 5 didn't work, 6 works. 7 didn't work, 8 did not work, 9 did not work, 10 did not work, 11 did not work. And so that is a complete list. 1, 2, 3, 4, and 6 are all factors of 12. Prime factorization is a special type of factorization where prime factorization of a number expresses the number as a product of its factors, and the factors must be prime numbers. So let's use that example of 12 again. If you took 12 and you decided to break it down into any 2 factors you want, let's say, for example, you chose 2 times 6. Again, both 2 and 6 are factors of 12 because they divide out evenly. But now the question is, are those 2 factors that we just wrote, 2 and 6, are they prime numbers as well? Remember, a prime number cannot be broken down any further unless you consider dividing the number by itself or by 1. And you would agree with me that 2 cannot be broken down any further other than taking a 2 or a 1 out. So 2 is a prime number. However, 6 is not. 6 can be broken down again because 6, in addition to being 1 times 6, is also 2 times 3. Okay? So now your next question is, okay, are 2 and 3, which make 6, prime numbers? And the answer is yes. Both of those are prime numbers. You can't break those down any further. And so to write 12 as a prime factorization, 12 could be written as 2 times 2 times 3. All three of those numbers are prime numbers, and if you work left to right, you would agree with me 2 times 2 is 4, and then 4 times 3 is 12. So this is the prime factorization of 12. Let's say that I asked you to do a prime factorization of the number 30. Okay? Now there's several ways you could factor 30. You could use 1 times 30, or you could use let's say 2 times 15 or 3 times 10. Several options there. Let's say you decided to use 5 times 6, which is 30. Now the next question you ask yourself if you want a prime factorization is 5 a prime number? Can you break that down any further? And the answer is no, you can't. It is a prime number. Okay. 6, however, can be broken down further. 6 can be written as 2 times 3. Notice when we talk about prime numbers, 1 is not itself considered a prime number. So we're not interested in breaking a number down as 1 times itself. Okay? So in this case, 6 will break down to 2 times 3. Both of those numbers are prime. You can't break those down any further except with a 1 or with itself. And so 30 in prime factorization is 5 times 2 times 3. 5 times 2 is 10. Times 3 is 30. All right, let's talk about equivalent fractions then. Fractions that represent the same portion of a whole or the same point on a number line are called equivalent fractions. And I have a couple of examples here on this slide. 6/8 represents 6 parts out of 8 whole. And if you draw a picture, if you think about it in terms of maybe, let's say, a candy bar, if that candy bar was broken down into 8 equivalent pieces, so let's say that you divided that candy bar like this, you'll notice that there are 1, 2, 3, 4, 5, 6, 7, 8 equivalent pieces representing that whole. When dealing with fraction work, the denominator always represents how many pieces represent the whole item that you're looking at. Okay? Now in this case, we're interested in 6 of those 8 pieces. So if we look at 6 of those pieces, and I'm just going to do this in a column method, we're looking at 1, 2, 3, 4, 5, 6 of those pieces. You'd agree with me that 6/8 of that candy bar is represented by that blue shading. Okay, now let's say that we looked at that same candy bar, and I'll try to draw it in an equivalent fashion over here, but instead of cutting it into 8 equivalent pieces, we decided to instead cut it in 4 equivalent pieces. So if we had here 1, 2, 3, 4 pieces, if that rectangle was the same size, and we were interested in 3 of those 4 pieces, we'd be interested in this piece, and this piece. This represents the same amount of candy as that, but in terms of fractions, it's slightly different. This represents 3 of 4 equivalent pieces of the whole candy bar, whereas this represents 6 of the 8 pieces of the whole candy bar. But they're equivalent, it's the same value. Okay, same value. You could think about it on a number line instead if you wanted to. If you're looking at a number line, and let's say you're interested in 1 representing your whole, you could take that distance on your number line, or on a ruler, if you're more familiar with a ruler, and you could cut it into 4 equal pieces. So you'd have 1/4, 2/4, 3/4, and 4/4. Okay, 1/4, 2/4, 3/4, and then 4/4. 4 divided by 4 is 1. Okay, and you are interested in 3 of those 4. You'd be interested in this piece, all the way up to the 3/4 mark. Okay, or again, if you had a ruler and you're interested in 1/8 markings, that would mean you'd have from 0 to 1, you'd have 8 equivalent pieces instead of 4. So you'd have 1, 2, 3, 4, 5, 6, 7, 8, okay, where each of these is an 8. This would be 1/8, this would be 2/8, this would be 3/8, and so forth. If you count 6 of those off, that would be 1, 2, 3, 4, 5, 6. 6/8 again is from here to here. And you can see on this ruler or on this number line, 6/8 is equivalent in length to 3/4. The fundamental property of fractions is a way to mathematically explain that. If you have a general representation where you have a fraction where a is your numerator and b is your denominator here, for either of these two examples here, the equivalent property of fractions says that as long as you have a fraction and b and c are not 0, if you take that fraction and you multiply or divide both the numerator and the denominator by the same non-zero number, the result is an equivalent fraction. And let's use that exact same fraction that we just used. We were saying visually, using the candy bar or the number line, that we know that 3/4 is equivalent to 6/8. Now, using multiplication or division and the fundamental property of fractions, how can we figure that out without drawing a picture? And the answer is you can either use multiplication or division, because the equivalent fundamental property of fractions for equivalent fractions says you can take a smaller fraction and multiply it, top and bottom, by the same number and get an equivalent fraction back out as long as you multiply or divide by the same number. So in this case, if we multiplied top and bottom, or numerator and denominator, of that fraction by 2, we would get 3 times 2 is 6, 4 times 2 is 8, equivalent fractions 3/4 and 6/8, as in the previous example. If we were starting with numbers that could both be divided evenly by a number, for example, if we took 6/8 and divided top and bottom by 2, that would give us 6 divided by 2 is 3, 8 divided by 2 is 4. Again, the same equivalent fraction, using division of the numerator and the denominator instead of multiplication. And you could do that with any number you wanted to. Let's say that you had this fraction, we'll say 10/15, and you wanted to find an equivalent fraction. You'd have to find a number that you could multiply or divide both top and bottom evenly by that number. So let's say, for example, you knew that you could divide both top and bottom here by 5 and get a nice whole number. 10 divided by 5 is 2. 15 divided by 5 is 3. You have an expression here then that says 10/15 is the same as 2/3. Let's say that you had this example. Let's say that you had 2/3 and you wanted to find an equivalent fraction, so you decided to multiply top and bottom by some value. Let's say you picked 7. If you multiply the top number by 7, 2 times 7 is 14. If you multiply the bottom by 7, 3 times 7 is 21. This says, according to the fundamental property of fractions, that 2/3 is equivalent to 14/21. Now let's use that to express fractions in simplest form. A fraction is in simplest form, or lowest terms, when the numerator and denominator have no common factors other than 1. There's 2 basic methods for this. The first method is you can use the fundamental principle of fractions that we just talked about to divide the numerator and the denominator of your fraction by the common factor of 7 in this example that I have up here, 14/21. Or you can use the prime factorization of both the numerator and the denominator and divide out the common factors. So looking at the first example here, where we're going to use the fundamental property of fractions, we want to find a value or a factor that we can divide both 14 and 21 by evenly. So we want it to be a factor. And we want to pick the biggest factor we can think of so that the resulting fraction can't be reduced anymore. We want it to be in lowest terms. The biggest number, or the biggest factor, that we can divide both 14 and 21 by evenly is 7. 7 is a factor of both of those numbers. So according to the fundamental property of fractions, if we divide both the numerator and the denominator by the same number, we will get an equivalent fraction back out. And as you can see, 14 divided by 7 is 2, 21 divided by 7 is 3, 14 21st, therefore, is equivalent to 2/3. Now, another way to do that, if it's hard to figure out what the greatest common factor is for both the top and the bottom, is you can take both the numerator and the denominator and break it down using prime factorization techniques, which means break it down until you can't break it down anymore. And then, if you have a common factor in both the numerator and the denominator, anytime you take a number and divide it by itself, that's equal to 1. 7 divided by 7 is 1. And anytime you take that value, okay, 7 divided by 7 is 1, if you multiply any number by 1, that just gives you the same number back out. So the shortcut way to do that is to recognize that if you have a common factor in both your numerator and denominator of a fraction, essentially they just cancel themselves out, because any number divided by itself is 1, and 1 times anything is just the same number back out. And so the two common factors don't really affect your final answer fraction. So let's do some examples of that to show you how to do some reducing of fractions using both those methods, and you can choose whichever method you like best. So for example, let's take the fraction 30 over 45, or 30/45, and let's reduce that to simplest form, or lowest terms, using both the fundamental principle of fractions method and then we'll do the same problem using the prime factorization method. Okay, so the fundamental principle of fractions says, look at the numerator and the denominator and pick the biggest factor of both numbers that you could divide both top and bottom by evenly to get an equivalent fraction. Now, 30 and 45, there are different factors you could pick. For example, both 30 and 45 would divide evenly by 5. But the largest number that both of those fractions would divide by is 15. Remember, you're trying to get the fraction into its lowest term. So if you divide both top and bottom of 30/45 by 15, 30 divided by 15 leaves you with 2, and 45 divided by 15 leaves you with 3, and you find that 30/45 is equivalent to 2/3. But because those are pretty big numbers, 30 and 45, it might be hard to find the largest or the greatest common factor that you could divide both of those by. So another option would be if you took 30 and you took 45 and you did a prime factorization of both of those. Okay, so in other words, break those numbers down until you can't break them down any further. 30, pick any two factors. Let's say you picked 5 and 6. 5 is a prime number, but 6 is not, so you can break 6 down some more. 6 is the same as 2 times 3. We can see that 30, which is the numerator of that fraction, can be rewritten as 5 times 2 times 3, prime factorization. Let's break 45 down as well. 45 you can write again several different ways. One would be 5 times 9. 5 is prime, but 9 is not, so let's break 9 down again. 9 is the same as 3 times 3. And so 45 in the denominator of your fraction can be rewritten as 5 times 3 times 3. Now remember we said when you have a fraction in factored form, if a factor appears in both the numerator and the denominator, then in essence you've just got 5 divided by 5 there, which is 1. They cancel themselves out. Notice you also have a matching factor in one of the 3's. The only thing left then that is not canceled out is a 2 in the numerator and a 3 in the denominator, and therefore 30/45 is equal to 2/3, which is the same thing we found using the other method, just a slightly different thought process. Okay, let's look at, for example, 12/30 using both methods. We want to reduce 12/30 into its simplest form. So if you choose to use the fundamental principle of fractions, you're looking for a factor that you could divide evenly out of 12 and 30, and you want it to be the biggest factor you can think of in terms of getting it into lowest or simplest form. 12 and 30 are both divisible by 6. They're also both divisible by 2, but we want to use the biggest number or the biggest factor we can think of. So 12 divided by 6 is 2, 30 divided by 6 is 5, and we find that 12/30 is the same as 2/5. Using the prime factorization method, if we take 12 and we break it down into prime factors, 12 is 2 times 6. 2 is prime, but 6 is not. 6 will break down to 2 times 3. Both of those are prime numbers. So we've got 12 is equal to 2 times 2 times 3. Now let's break 30 down. 30 is the same as 5 times 6. 5 is prime, but 6 will break down again. 6 is 2 times 3. Both of those are prime. So we find that 30 is equivalent to 5 times 2 times 3. Notice that there is a 2, both top and bottom, in this fraction, and they'll cancel out. There is a 3 as well that's common, both top and bottom, so they also cancel out. Remember, that's equivalent to multiplying by 1. What we're left there then with is the 2 and the 5, and so we find, as we did before, that 12/30 is the same as 2/5. Same answer, two different methods. You should pick the one that makes most sense to you and the one that you can use most consistently. Helpful hint. Notice that when you are taking fractions and you are reducing them, if everything reduces out, for example, if you look at this example here, notice that we had a pair of 5s that we could cancel out using that prime factorization method. If everything cancels out, often students think then that they can just ignore that numerator or that denominator, or sometimes they even try to put a 0 in there. But if everything cancels out, or if all the factors of the numerator and denominator are divided out, there is a 1 that is still left. Not a 0, and you can't just ignore the numerator or denominator. You do need to put a 1 in. So here, notice that our 5s cancel out. That 5 was the only thing in the numerator, and so then there's a 1 as a placeholder left in there. In other words, 5 divided by 5 leaves you with 1. Over here, same kind of deal. In this case, notice that the 3's canceled out, and since 3 was the only thing in the denominator, there is a 1 left there. But then in this particular example, unlike this one over here, you can do one more step, because fractions are just a fancy way to write division. So 5 over 1 is the same as 5 divided by 1. Anything divided by 1 is itself. And this is always considered better form if you can write it without a fraction than writing it with a fraction. Okay, so now let's move on to a review of multiplying and dividing fractions. Starting with multiplication, when you are multiplying two fractions, if you look at the example in the middle of this slide where we've got two fractions, a over b and c over d, and it's important that you know that b and d are not 0 because division by 0 is not allowed. That's considered undefined. For example, if you had 5 divided by 0, that is something that's not allowed in math. There is no number that describes that. That is undefined. Okay, so for this example, as long as b and d are not 0, it turns out that if you multiply those two fractions, a over b times c over d, the answer will simply be the product of the numerator, a times c, over the denominator product, b times d. In other words, to multiply two fractions, multiply the numerators and multiply the denominators. For example, if you were doing 3/2 times 5/7, as long as the denominators are not 0, and they aren't, then you can get your equivalent fraction by simply multiplying your numerators. 3 times 5 is 15. Multiplying your denominators, 2 times 7 is 14, and that is your final answer. If the numerators have common factors with the denominators, divide the common factors out before multiplying. Now this is a shortcut and one that is not necessary unless you want to do that. In this case, 3/4 times 2/5, again using the simple rule above, multiply your numerators, 3 times 2, multiply your denominators, 4 times 5, and this comes from when we talked about reducing using the prime factorization method. Notice that, as with that, if you have a common factor top and bottom, you can save yourself from reducing at the end by canceling those values out before you do the final multiplication step. That's not necessary. If you miss that, you could just take your final answer and reduce it then. Either way, you're going to get 3/10. For example, let's say you didn't notice you had a common factor here. So you went ahead and multiplied 3 times 2, which gives you 6. And in your denominator, 2 times 2 is 4, times another 5 is 20. So let's say that you did not cancel on that intermediate step. At this point, though, the rule in math always is you always want to write your final answer in simplest form. So at this point, you would have to use one of those two methods we just talked about, either divide top and bottom by the greatest common factor, or you could do a prime factorization, which is what this is, and cancel out. At this point, if you know that there is a common factor here of 2, you could divide it out at this step, and that would give you 3 over 10, which is the same answer, just a little more writing. All right, and notice that you could even shorten that up further if you notice that at this point, this is the original problem, notice this and this are the same. With multiplication only, if you recognize across a diagonal or within the same fraction there's a common factor, you actually could reduce this before you ever wrote it like this and save yourself some paperwork there too. There is, with this 2 and this 4, a common factor of 2. So you can, this is called cross-canceling, you can divide top and bottom by 2 here. 2 divided by 2 is 1. 4 divided by 2 is 2. Save yourself some paperwork. 3 times 1 then is 3. And 2 times 5 is 10. Note that this shortcut step right here can only be done on a multiplication problem. You cannot do that cross-canceling if you're adding or subtracting or dividing. That's a shortcut step only for multiplication. So let's look at some more examples. We're going to throw a variable in there as well, which is just a letter that represents a number. And all of the same fraction rules will apply to those as well. Let's say you were doing 3x divided by 4 times 8 divided by 5x. If you wanted to multiply top and bottom together first and do a prime factorization at the same time, 3 is a prime number, but you know that 8 will break down to 4 times 2. And technically, if you were doing a prime factorization, you'd have to break that 4 down into 2 times 2 as well. So you could write this as 2 times 2 if you wanted. Okay? So 3 times x times 8 is the same as 3 times x times 4 times 2, or 3 times x times 2 times 2 times 2. Okay? Our denominator, 4 times 5x, is the same as 4 times 5 times x, or again, if you were doing a prime factorization, you'd write that 4 as 2 times 2. Then cancel out whatever is common. You've got a 2 that's common, and a 2 here that's common, or if you left it as a 4, you'd be canceling that 4 out. You've also got a common variable, a common letter, top and bottom, so those also will cancel out. And then do the multiplication of what's left. 3 times 2 is 6. The only thing left down here is 5. Final answer is 6/5. Shortcut to that, again, you can only do this with multiplication. Notice if you look at the numbers across the diagonal here, there's a common factor of 4. We could divide 4 top and bottom here. 4 divided by 4 is 1. 8 divided by 4 is 2. And here you have a common factor of x that you can cancel out, leaving you with 3 times 2 is 6, and 1 times 5 is 5. Another way that you could do that same problem, if you missed any of those steps, is if you simply multiply the entire numerator. 3 times x times 8 is 24x. And then do the whole multiplication step in the denominator. 4 times 5 times x is 20 times x. And then reduce this, okay, using one of the two methods we talked about, either divide out a common factor or do a prime factorization. Here, you can take out a greatest common factor of 4, top and bottom. 20 divided by 4 is 6. I'm sorry, 24 divided by 4 is 6. 20 divided by 4 is 5. In addition to being able to divide out that 4, you could also take out an x. Now, this is really a little farther down the road, and so we'll talk in detail about this when we get into the variable portion of this class. But you could divide the x out as well, and anything divided by itself is 1, so the x's are gone. And the answer is 6/5. All right, another helpful hint. Recall that when the denominator of a fraction contains a variable, such as 8 divided by 5x, notice that that variable or that letter is in the denominator, we assume that the variable is not 0. Why? Because division by 0 is never allowed. So let's look at a few more examples. Let's look at this problem. You're asked to multiply the fractions. Say we've got 2/3 times 5/11. Remember, when you multiply fractions, you simply multiply the numerators and multiply the denominators. With multiplication, if there's a common factor you could divide out before you multiplied, you're welcome to do that as well. So, if we decided just to go ahead and multiply the numerator and the denominator, we'd have 2 times 5 over 3 times 11. 2 times 5 is 10. 3 times 11 is 33. There are no common factors we could take out. We can kind of see that in the previous step as well. Therefore, this is simplest form, and therefore that would be our final answer. Let's say that we had 6/7 times 14/27. Okay, there's a couple of ways we could do this problem. If we wanted to write it as a single fraction before we did anything else, we'd have 6 times 14 over 7 times 27. And then let's say we decided to write each of those numbers in prime factorization so we could reduce before we got our final answer. Because we can see that 6 times 14 is going to be a pretty big number, and 7 times 27 also is going to be a pretty big number. So let's just break all of those numbers down. 6, if you break that down into prime factors, is 2 times 3. And 14 is the same as 2 times 7. Down here in the denominator, 7 is a prime number, so we can't break it down any further. Now, 27 is the same as 3 times 9, and then 9 can be broken down further into 3 times 3. So 27 can be written as 3 times 3 times 3. Now, look for common factors top and bottom to cancel out. Notice that we have a matching pair of 7s. We have a matching pair of 3s. And that gives us, if you do that multiplication, 2 times 2 is 4, and 3 times 3 is 9. And our final answer in reduced form would be 4/9. Let's do one more. Let's say we had 23 over 32 times 4/7. Again, if you write that in combined form, that's 23 times 4 over 32 times 7. Those are going to give us pretty big numbers, so if we can break any of those down, I think that it will be easier for us if we do. 23, unfortunately, is a prime number, so we're going to have to leave that as 23. 4, though, can be rewritten as 2 times 2. Down here in the denominator, I'm going to write this underneath here. 32 is 4 times 8. That 4 can be broken down to 2 times 2. That 8 can be broken down to 4 times 2. So we've got prime numbers there with those 2's, but the 4 again can be broken down. And so after doing a prime factorization of 32, we've actually got a series of 5 2's. And if you multiply that, 2 times 2 times 2 times 2 times 2, that does equal 32. And then don't forget the 7, which is prime. Now, cancel out what's common. You've got a pair of 2's that are common here and a pair of 2's that are common here. Those are the only things that match that we can cancel out. So our final answer here should be in simplest form. The only thing we're left with in our numerator is 23. And in our denominator, we've got 2 times 2, which is 4, times 2, which is 8, and 8 times 7 is 56. And we can be confident that that is our final answer. All right, let's talk about the reciprocal of a fraction. Two numbers are reciprocals of each other if their product is 1. The reciprocal of the fraction, a over b, is b over a. So really, to find a reciprocal, the numerator becomes the denominator, and the denominator becomes the numerator. So we just flip it over. And notice that according to the definition, you can tell if two numbers are reciprocals if you take a number and its reciprocal and you multiply them together. It turns out that your final answer is always 1. Okay. So if I asked you, for example, to find the reciprocal of the following numbers, it's very simple. Let's say that I asked you to find the reciprocal of 3/4. Reciprocal simply means flip it over. Let the numerator become the denominator become the numerator. So the reciprocal of 3/4 would be 4/3. If I asked you to find the reciprocal of a number that had a negative sign attached to it, the negative does not change. It just flips with the rest of the fraction. Okay? So to find the reciprocal of -2 over 3, flip it over. The 3 is now the numerator, and the -2 is down in the denominator. If you're asked to find the reciprocal of, let's say, 1/5, your first step, again, would be to flip it over. So you'd have 5 over 1, but then always simplify that further if you can. 5 over 1, anything divided by 1 is itself. So 5 over 1 is 5. And let's say you were asked to find the reciprocal of a whole number. Remember that anytime you have a whole number, you can make that into a fraction by putting the number in the numerator and putting a 1 in the denominator. Now again, as with the previous example, anything divided by 1 is itself. So 2 is the same as 2 over 1, but now that it's in fraction form, it's a little easier to think about in terms of reciprocal work. If you flip 2 over 1 over, you get a reciprocal answer of 1/2. Okay, so let's move on to dividing two fractions then. To divide fractions, we are going to change the division problem into a multiplication problem and solve as before. So really, division problems are exactly the same as multiplication problems with one extra step. Okay? If you have a problem a over b divided by c over d, that's equal to taking the first fraction and leaving it alone. Notice we don't change the first fraction. Then we change division to multiplication, and that works only if we take the reciprocal of the second fraction. Notice we flipped it over. C over d became d over c. Now we have a multiplication problem, and as we just talked about, we can simply multiply the numerator and the denominator together to get our final answer. So using real numbers down here, we've got 3/5 divided by 2/7. That's the same as if we take the first fraction and we leave it unchanged, change division to multiplication, and that works only if we take the reciprocal of the second fraction. So flip 2/7 over to give us 7/2, and then do the multiplication. 3 times 7 is 21, and 5 times 2 is 10. And that is simplest form. Remember, you always want to reduce your final answer to simplest form if needed. But there are no common factors to reduce that with. Helpful hint: when dividing by a fraction, do not look for common factors to divide out until you rewrite the division as multiplication. And that's what we said before. If you're going to use those little shortcut steps where you can cancel out a common factor, a common mistake is students will look at this problem and they'll see that there are common factors of 2 across the diagonal here, and they'll try to cancel them out. You can't do that if it's division. The only time you can cross-cancel is if it's multiplication. So you have to take this problem as written and change it to a multiplication problem first by rewriting the first fraction, changing division to multiplication, and then taking the reciprocal of the second fraction. So 2/3 becomes 3/2. Now notice that the 2's here are no longer on the diagonal from each other, so you cannot cancel them. All you can do is multiply. So you've got 1 times 3 is 3, 2 times 2 is 4. That can't be reduced. That is your final answer. So always change division to multiplication before you try to reduce. So let's look at some division problems. Remember, again, division of fractions is exactly the same as multiplication of fractions with one extra step. So we're going to look at 3/4 divided by 2/5. Okay, first step, don't do any reducing. Change it to a multiplication problem. So we're going to take 3/4 and we're going to change division to multiplication by taking the reciprocal of the second fraction, flip it over. That becomes 5 over 2. Now at this point, let's do the multiplication. We've got 3 times 5, and we've got 4 times 2. You could, if you wanted to, break that 4 down to 2 times 2 if you were using the prime factorization method. Notice, though, that doesn't really help us any, because 3 times 5 in the numerator and 2 times 2 times 2 in the denominator, there's nothing common top or bottom. So we're stuck just doing the multiplication. It doesn't reduce. 3 times 5 is 15. 2 times 2 times 2 is 8. And our final answer is 15/8. Let's look at this problem. Let's look at 2/3 divided by 4/9. 2/3 divided by 4/9 is the same as 2/3 times, change it to multiplication, take the reciprocal, 9/4. 2/3 times 9/4 then is the same as, multiply the numerators, 2 times 9, multiply the denominators, 3 times 4. Now if you wanted to do a prime factorization here, you could. Notice that 2 is prime, but 9 can be further broken down to be 3 times 3. Down here in our denominator, we've got 3 times 4 can be broken down to 2 times 2. Look for common factors. We've got a pair of 3's that'll cancel, and we have a pair of 2's. And then the only thing we are left with is 3/2 as our final answer. Okay, one more example. Let's look at 7/8 divided by 21. Remember, you can take any number that isn't a fraction and make it into a fraction by putting it over 1. So that's what I'm going to do. I'm going to make it look like a fraction divided by a fraction. Now, doing exactly what we did before, we've got 7/8 times, take the reciprocal of this second number, 1 over 21. Look for common factors, or go ahead and do the multiplication and reduce then, or do a prime factorization if you want. Just because we did a prime factorization above, I think that I'm going to use the other method for this. Notice that if you look across the diagonal here, and this is okay only because this is multiplication, I can see here that there's a common factor of 7 that I could divide out top and bottom. Now, if this doesn't make sense to you, do it like we did this problem. Do a prime factorization. Here, 7 divided by 7 is 1. 21 divided by 7 is 3. Now I'm left with 1 times 1 in our numerator, and our denominator is 8 times 3. 1 times 1 is 1. 8 times 3 is 24. Final answer is 1/24. All right, final topic is adding and subtracting fractions. Okay, to add and subtract fractions, we need to understand what like and unlike fractions are. Fractions that have the same or common denominator are called like fractions. Fractions that have different denominators are called unlike fractions. So some examples of like fractions might be 2/5 and 4/5. Notice the denominator of 5 is the same. Or 5/7 and -3/7. Again, doesn't matter if they're positive and negative. The only thing that matters is if the denominator matches and both are 7s. Unlike fractions will have different denominators, so 2/3 and 3/4, 3 and 4 are different. 5/6 and 5/12, although the numerators match, the denominators don't, and it's the denominators that have to match to be considered a like fraction. Adding or subtracting like fractions. If you are adding and subtracting fractions and you have like fractions, which means the denominators match, then to add or subtract fractions with the same denominator, add or subtract their numerators only and write the sum or difference over the common denominator. So notice that unlike multiplication, you only do the addition step or the subtraction step with the numerator, and the denominator just carries along. It just rewrites. You don't add or subtract the denominator, only the numerator. Helpful hint, don't forget to write your answer in simplest form. If it is not a simplest form, divide out all the common factors larger than 1, or do that prime factorization and cancel out any common factors. Also, note that all of the fractions below represent the same quantity. That is, they are equivalent negative fractions. So what this means is when you're dealing with negative values, it doesn't matter whether the negative sign is in the numerator or the denominator, or maybe both. It simply is a function of how many negative signs that you have. So here, negative 2 over 3 is the same as 2 over negative 3. Doesn't matter that we shuffled the negative sign down. If you have, again, an odd number of negative signs, you've got 1 here, 1 here, and 1 here. As long as you have an odd number, that's the same. And you could also pull that negative out in front so it wasn't in the numerator or the denominator, and those would all still be equivalent. So let's do some examples of adding common denominators. Let's say that we were looking at this problem. We've got 1/2 plus 5/2. First thing you want to do is look at the problem and ask, what kind of problem is it? It's an addition problem. So the next thing you want to ask yourself is it an addition problem that has a common denominator? And the answer is yes, it does. So the rule is you will add the numerator only and the common denominator just rewrites. Okay? In this case, you've got 1 plus 5 is 6 over 2, and that can be further reduced. Remember, fractions are simply division. 6 divided by 2, or if you wanted to think about it like this, there's a common factor of 2 there we could divide out. 6 divided by 2 is 3. 2 divided by 2 is 1. Anything divided by 1 is itself. You could also use that prime factorization method to reduce that if you wanted. All right, let's say that we had this problem then. Let's say that we had negative 11 over 8 plus 6 over 8. Now you might look at that negative sign and not know what to do with that because you don't know whether the negative applies to the entire fraction or whether you should put it with the 11 or whether you should put it with the 8. Remember, the previous slide said it doesn't matter which number you decide to put that with. And since all of the math in addition and subtraction go with the numerator, I'm going to shuffle that negative up with that 11. So I'm going to rewrite it so it's obvious to me that I've got that negative sign up there with the 11. So now again, negative 11 over 8 plus 6 over 8. We've got a common denominator, so I know my answer is going to be over that common denominator. Do the addition up top. Negative 11 plus 6 is the same as negative 5 over that common denominator of 8. There is no common factor I could reduce that with, and that would be my final answer. Subtraction is the same way. Let's say that we were doing this problem, 3/7 minus 6/7. We have a matching denominator, so my answer will be over that common denominator. Do the operation up top in the numerator, 3 minus 6. 3 minus 6 leaves us with negative 3 and our 7 in the denominator. You can't reduce that, so this is your final answer. If you wanted to leave that negative up with the 3, you could. You could also pull that negative in front of the entire fraction if you wanted. Another option is you could put the negative with the 7, although you rarely see a final answer with a negative in the denominator if there's another choice. All right, now let's look at this problem. Let's say that you have 5 over negative 9 plus 1 over 9. Now we're talking about addition and subtraction with common denominators. But if you look at this, as written, we don't have a common denominator. One of the denominators is negative 9, and one of the denominators is a positive 9. Those are not the same. But using that rule that we talked about with equivalent negative fractions, we know that we could take that negative sign and we could pull it up with the numerator instead, and that would be the same fraction. So that's what we're going to do. Instead of writing that first fraction as 5 over negative 9, we're going to rewrite it, because it's the same, as negative 5 over positive 9. Either way, it's negative 5/9. But the reason that that's an advantage to us is now we have a common denominator. We have positive 9 in both fractions, so we can now simply add our numerator, negative 5 plus 1. Negative 5 plus 1 is negative 4 over 9. That can't be reduced, and so that is our final answer in that example. All right, least common denominator. This is going to apply for situations where you don't have common or like fractions, no common denominator. To add or subtract fractions that have unlike or different denominators, we write the fractions as equivalent fractions, which we talked about earlier in the video, with a common denominator. The smallest common denominator is called the least common denominator, or the LCD, or we're going to use the least common multiple, LCM, to find the least common denominator. So the least common denominator of a list of fractions is the smallest positive number divisible by all of the denominators in the list. The least common denominator is also the least common multiple of the denominators. So that's a lot of terminology that a lot of times students get thrown at them. Really, it's basically the same thing. So, least common denominator. Let's say you have two fractions. You have 5/12ths and you have 5/18ths. And let's say you have a problem that is asking you to add or subtract those. Remember, a common denominator is only needed if you're adding or subtracting. If you're multiplying or dividing, we didn't worry about whether our denominators matched. But for adding or subtracting, we are concerned about whether our denominators match or whether we have like fractions. So, here's what we're going to do. We want to take those fractions and find an equivalent fraction so that the denominators are the same. So first, we're going to write each denominator as the product of their primes. So notice we have our two denominators. We're just looking at those for now. We've got our 12 and our 18, and we do a prime factorization. 12 is the same as 4 times 3, and then, of course, 4 can be broken down as 2 times 2 times 3. 18, same deal. You can break 18 down, and prime factorization would be 2 times 3, which is 6, times 3 is 18. So 2 times 3 times 3. Now what we're going to do is we're then going to write each factor the greatest number of times it appears in any one factorization. Okay? So notice that for both of those numbers, we have two different types of factors. We have factors of 2 that appear in those numbers, and we have factors of 3. But depending on the number, they appear a different number of times. For example, in 12, we've got 2 2's, and in 18, we've only got 1. Okay? We've also got a factor of 3. That 3 appears once in that first number and twice in that second number. So we are interested in any one factor, what is the greatest number of times a factor appears. That will give you, if you combine those and multiply them, that will give you the least common denominator for those two numbers. So here's what that means. Let's look at the factor of 2. In 12, 2 appears twice. In 18, the factor 2 appears once. The larger of those two is appearing twice, and so that's how many times it has to appear in the least common denominator, 2 times 2. 3 appears once here, but twice here, and you have to go with the largest number of times it appears. So because 3 appears twice here, it will also have to appear twice here. If you multiply all those values together, 2 times 2 times 3 times 3 is 36. That will be the least common denominator for 12 and 18. So let's go back to that a minute. So let's say then that this problem was asking you maybe to add these two values together. In order to add those numbers, we want to make those two fractions have a common denominator. we know that the smallest common denominator that we can work with both of those numbers is 36. So we know that using equivalent fractions, we can force this 12 to be a 36 by multiplying it by 3. 12 times 3 is 36. But when we talked about equivalent fractions, we said if you're going to multiply the denominator by 3, you have to multiply the numerator by 3 as well, or it won't be an equivalent fraction. 18, in order to make 18 into a 36, we'll have to multiply it by 2. 18 times 2 is 36. But we have to multiply our numerator by the same thing in order to have an equivalent fraction. So now we have here 5 times 3 is 15 over 12 times 3 is 36 plus 5 times 2 is 10 over 18 times 2 is also 36. We're now adding like fractions, so we know that our answer will be over that common denominator. Sorry, let's bring that down here. Common denominator. Do the math up top. 15 plus 10 is 25/36. And then you want to ask yourself, can I reduce that? Are there any common factors that might allow me to reduce that? Well, if we do a prime factorization, 25 is 5 times 5. 36, a couple of different ways we could work that. We've got 2 times 18, we know. 18 will break down to 2 times 9, and 9 will break down to 3 times 3. But notice that out of all of those factors, we've got 2's and 3's in our denominator and 5's in our numerator. Nothing matches, therefore nothing will cancel. Therefore, 25 over 36 is our simplest form for that problem. So let's summarize that. When you are adding or subtracting fractions that are not like fractions, in other words, their denominators do not match, your first step is to find the least common denominator of all of the denominators of the fractions in the addition or subtraction problem. Your second step is to write each fraction as an equivalent fraction, as we just did, whose denominator is the least common denominator. Then add or subtract the fractions because now they have a common denominator, and then write the sum in simplest form. So let's look at an example. Let's say you were going to add 1/9 plus 7/12. The denominators there, you would agree, do not match. So we're going to make them match so we can simply add or subtract the numerators. So to figure out the least common denominator, we said one method is to take each denominator and do a prime factorization. So if you do a prime factorization of 9, you get 3 times 3. And if you break 12 down completely, 12 is 4 times 3, and 4 breaks down to 2 times 2, so you have 2 times 2 times 3. Now, look at all of the factors in those two denominators. Let's start with 3's. Notice that there are 2 3's that appear in the 9, and there's 1 3 that appears in the breakdown of 12. Pick the bigger of those 2 times to write. Okay? Since 3 appears twice here, it also has to appear twice here in the least common denominator. Factor of 2 doesn't appear at all in 9, but it does appear twice here, therefore it will appear twice in the least common denominator. There are no other factors, there's just 2's and 3's, so multiply all those together. 2 times 2 is 4, times 3 is 12, times 3 is 36 for your least common denominator. Second step, rewrite the equivalent fractions with the least common denominator. Take 1/9 and force that 9 to become a 36, because that's your least common denominator, by multiplying it by 4. 9 times 4 is 36. But you know that if you multiply your denominator by 4, you have to multiply your numerator by 4 as well. And so you get 4/36 as the equivalent fraction for 1/9. Here, 7/12. To make a 12 into a 36, you have to multiply it by 3, multiply the numerator by the same, and you get an equivalent fraction of 2136. Okay, so we're going to add those then. So here is our addition step. 436 plus 2136, we have a common denominator, so just do the math up top. 4 plus 21 is 25, and we've got 2536 as our final answer. Reduce that if you can. In that case, though, that doesn't reduce, and that is your final answer. All right, so let's look at some other examples. Let's say that you're asked to add 2/5 to 4/15. Okay, it's an addition problem, so you need a common denominator. As written, you do not have a common denominator, so we're going to find a common denominator for that. So looking at each denominator individually, if you did a prime factorization of 5, 5 is the same as 5 times 1, or just 5. Remember, we're not interested in ones. 5 is a prime number. Okay? 15, if you broke it down into its prime factorization, 15 breaks down to 3 times 5. The least common denominator will be a combination of those factors, and you have to write those factors the maximum number of times it appears in any one denominator. So let's start with a factor of 5. There is a factor of 5 that appears in both of those denominators. In each it appears once, so it'll appear once in the least common denominator, the LCD. There's also a factor of 3. It appears once in the second denominator and not at all in the first denominator, so it needs to appear once in the LCD. Multiply those two factors together, and we find that the least common denominator for this problem is 15. So, going back to the original problem, notice that only the first fraction does not have 15 in the denominator. So we're going to have to take that first fraction and we're going to have to build it up so that it has a common denominator of 15. So multiply top and bottom by 15. And then we're going to add that to our second fraction, 4/15. We don't have to do anything with this fraction because that denominator already is 15. So now we've got 6/15 plus 4/15. Common denominator, add the numerators only. 6 plus 4 is 10 over 15. Then you need to reduce that fraction. You can do a prime factorization if you want, or you might just recognize there's a common factor of 5. You can divide out top and bottom. 10 divided by 5 is 2. 15 divided by 5 is 3. Final answer of 2/3. Okay, let's do this problem. Let's say you were doing -2/15 and you are subtracting 3/10. Again, with addition or subtraction, you do need a common denominator. Those fractions don't have a common denominator, so we're going to do a prime factorization of each denominator. First denominator is 15, second denominator is 10. Let's break that down completely. 15 is the same as 3 times 5, and there's nothing further you can do there. 10 is the same as 2 times 5, and again, those are both prime numbers, nothing further you can do. The least common denominator then will be those factors written the maximum number of times it appears in any one denominator. So let's start with the factor of 3. It appears once in 15 and not at all in 10, so it'll appear once in your common denominator. The factor 5 appears once in the numerator, once in the denominator, so once for each would just be once in the denominator. And then the factor of 2 appears not at all in 15, but once in 10, so it's got to appear once in the least common denominator. Do that multiplication. 3 times 5 is 15. 15 times 2 is 30. So we need a common denominator of 30 here. So coming back to the original problem, we need to force each of these denominators to be 30. 15 times what gives you 30? Well, 15 times 2. So we're going to have to multiply the first fraction top and bottom by 2. Okay, then the second fraction we need to force to be a 30 as well. 10 times what is 30? Well, the answer is 3. 10 times 3 is 30. Multiply top and bottom by 3. Now you've got negative 2 times 2 is negative 4 over 30, minus 3 times 3 is 9 over 30. We now have a common denominator, so we can do the math up top and write it over the common denominator. Negative 4 minus 9 is the same as negative 13 thirtieths. Can't be reduced. That is your final answer for that particular problem. So let's summarize all that. In summary, equivalent fractions can be found by multiplying or dividing the numerator and denominator by the same number. When adding or subtracting fractions, you must have a common denominator. Add or subtract the numerators only and keep the same denominator. When multiplying or dividing fractions, you do not need a common denominator. Change all division problems into multiplication problems by multiplying by the reciprocal of the second fraction. Multiply both the numerators and the denominators together. And finally, for any fraction problem, reduce all final answers to simplest form. This brings us to the end of Module 6, the fraction review material. You should now complete the homework for the fraction review found in MyMathLab. And when you have successfully completed the fraction review homework, proceed to the video for Module 6, Section 1.3.